In Part 4, we'll apply the tools we now have to examine why costs are most often lower in the long run, and why some firms experience cost savings when producing multiple goods instead of a single type of output. Short-run costs are confined within the firm's long-run decisions. In its long-run plans, the firm decides on the scale of production it will undertake, and so it chooses a plant size and makes other investment decisions aiming to minimize long-run costs. Once the firm has determined its plant size and set up other equipment, these inputs are fixed in the short run. Thus, the firm's long-run decision determines its short-run cost. Since some inputs cannot be varied in the short-run cost is at least as high as long-run cost. In the long run, the firm has more flexibility in its choice of inputs and more options for lowering its cost. Because of the more limited options the firm has in the short-run cost is higher than long-run cost if the firm chooses the wrong level of the fixed inputs, or at best, short-run cost is as low as long-run cost. In other words, long-run average cost is always equal to or below short-run average cost. We can illustrate this by plotting the firm's short-run average cost curves for different quantities of the fixed inputs and relate these to the firm's long-run average cost curve. For example, in Figure 7.9, suppose the firm can choose one of three plant sizes, small, medium, or large, in the long run. Short-run average cost 1 relates to the firm's small plant size. Short-run average cost 2 corresponds to the medium plant size the firm can choose if it plans on producing more output. And suppose that short-run average cost 3 reflects the large plant size that the firm can opt for if it wants to produce large amounts of output in the long run. The long-run average cost curve forms an envelope around the short-run average cost curves. The limitations of the firm's short-run choices can be seen here. If the firm wants to produce Q1 units of output, and if it has set up the smallest plant size, its average cost is at point A on short-run average cost curve 1, showing that its average cost is $10 per unit. But if it has chosen the bigger plant size, or the medium plant size, corresponding to short-run average cost 2, Q1 can only be produced at an average cost of $12 per unit at point B. Hence, the most suitable plant size for output level Q1 is the small plant size, while the best plant size for producing at Q2 is the medium plant size. On short-run average cost 2, the firm can enjoy the lowest average cost at point E, rather than the much higher average cost at point D if it was stuck with the small plant size but producing at Q2 units of output. To sum up, in the long run the firm will choose the most suitable plant size, minimizing its cost for the relevant output level. It is clear that the firm has more flexibility in the long run, and hence long-run cost is no higher than short-run cost, but usually lower. We can illustrate this flexibility with the short-run and long-run expansion paths of the firm. These are shown for the beer manufacturer in Figure 7.10. In the short run, capital is fixed at 100 units, so the short-run expansion path is horizontal. The firm can only increase its output by increasing the amount of labor it uses. In the short run, the beer manufacturer can expand its output from 100 to 200 units by raising the firm's cost from $2,000 to $4,616. Expanding output from 100 to 200 units in the long run comes with a smaller rise in cost from $2,000 to $4,000. In the long run, the expansion path traces the tangency points between each isoquant and the corresponding lowest attainable isocost. The long-run expansion path is upward sloping because the firm varies both inputs to expand output at minimum cost in the long run. A producer may enjoy lower average cost over time for three reasons. First, expanding production may benefit the firm if its technology exhibits increasing returns to scale. Second, technological progress may increase the productivity of some or all of its inputs and result in cost savings. Third, the firm may benefit from the accumulated experience of workers and managers, which makes them more productive and lowers cost. This is referred to as learning by doing. We examined the first two reasons, that is, increasing returns to scale and technological progress, in Chapter 6. Now we turn our attention briefly to the third reason. Learning by doing is the productive skills and knowledge that workers and managers gain from experience. Simply put, workers and managers get better at what they do through practicing their tasks, finding better ways of performing them, and problem solving over time. The learning curve captures this relationship. It is the relationship between average costs and cumulative output. If a firm is operating on the economies of scale portion of its long-run average cost curve, its cost will fall for two reasons. First, expanding production reduces cost because of economies of scale. And second, for any given level of output, average cost is lower in a subsequent period because of learning by doing. Figure 7.11 illustrates this. Panel B on the right shows that on a given average cost curve, say AC1, the firm's average cost falls as output rises from point A to B to C in period 1. But the firm's long-run average cost also shifts downwards as its staff gain experience through learning by doing over time. It shifts from AC1 to AC2 in the next period and then to AC3 in the period after that. Panel A on the left captures the learning curve of an electronics firm, Intel, that produces central processing units. Average cost is on the vertical axis, but its cumulative output over time on the horizontal axis, rather than output per period, as is the case of the average cost curve. We can see that Intel's cost falls rapidly with the first few million CPUs, then declines more gradually with additional output. We assumed that each firm produces a single good for simplicity, but many firms produce multiple goods. In this case, the cost of producing one good may depend on the cost of producing the others. For example, Sasol produces synthetic fuels using an oil from coal technology in its plant in Secunda, which is the largest of its kind in the world. The process also results in ammonia gas being released as a byproduct. If Sasol were to produce only oil, the ammonia gas would be a waste product. Instead, it collects and uses the ammonia in the production of other chemicals, for example, fertilizers. In general, if goods are less expensive to produce jointly than separately, we refer to the firm enjoying economies of scope. A measure of the degree of economies of scope for a manufacturer of two goods is shown here. CQ1, 0, is the cost of producing Q1 units of the first good and none of the second good. C0, Q2, is the cost of producing Q2 units of the second good and none of the first. CQ1, Q2 is the cost of producing both goods jointly. If the cost of producing the goods separately is the same as producing them together, then the economies of scope measure is 0. There is no benefit from economies of scope for the firm. If it's cheaper to produce jointly, then the economies of scope measure is positive, implying economies of scope. It is also possible that the production of one of the goods interferes with the production of the other in unfavorable ways. In this case, producing the goods jointly will be more expensive than producing them separately, and the measure of economies of scope will be negative. We can use a familiar concept, that of the production possibility frontier, to illustrate economies of scope. Recall that the production possibility frontier shows the maximum amount of outputs that can be produced from a fixed amount of input. Let's consider an example. Suppose that Chef Laura spends 1 day a week in a nearby forest collecting mushrooms and wild strawberries for her restaurant. Her production possibility frontier shows the maximum amounts of mushrooms and wild strawberries Laura can collect in 1 day of walking in the forest. You would probably remember that the ppf also reflects the trade-off Laura faces. She picks fewer mushrooms if she collects more strawberries in a day. If she spends the day collecting only mushrooms, she can get a maximum of 8 kilograms. If she collects only strawberries, she can get a maximum of 6 kilograms. However, if Laura picks mushrooms and strawberries as she walks along, she can collect a bigger total amount, for example 4 kilograms of strawberries and 6 kilograms of mushrooms. This is the reason the blue ppf in figure 7.12 is bowed out or concave to the origin. The shape reflects diminishing marginal returns from collecting only one of the goods. If mushrooms and strawberries grow in the same area, it involves more effort to collect them separately, but Laura enjoys economies of scope on her efforts if she picks both. However, if mushrooms and strawberries grow in different parts of the forest, then Laura can collect mushrooms without passing by any strawberries. In this case, the ppf is a straight line, as illustrated by the green ppf. Laura can divide her time between the different parts of the forest, and her returns from collecting only mushrooms or only strawberries do not diminish, so there are no economies of scope. This completes Chapter 7 in Part 1 of the course.